In this video for section 9.1, we're going to talk about how to conduct a hypothesis test and how to write the null and alternative hypotheses. So we have this example of a machine that is supposed to fill orange juice bottles with 32 ounces of orange juice. Now we can't open every single bottle and check to make sure that it's filling them with 32 ounces. So instead we take a sample of 10 of the bottles and we find the average amount of orange juice in the bottles. If it is 31.9 ounces, is this close enough to 32 that we can assume that the machine is doing its job? What if the mean is 31.5 ounces or 31 ounces? Are those close enough to 32 that we can assume that the machine is doing its job? Or are they significantly lower than 32, and so that tells us that the machine is not filling the bottles properly? So one way that we can answer this question is by conducting what's called a hypothesis test. And we start a hypothesis test with writing our null and alternative hypotheses. The null hypothesis always contains an equality sign, which is equal to, greater than or equal to, or less than or equal to. Remember those lines underneath the greater than or less than symbols mean equal to. And we abbreviate the null hypothesis sometimes with this H sub 0. You'll see that a lot in this class. And so again, null hypothesis, equality sign. Alternative hypothesis always contains an inequality sign, which is a not equal to, a greater than, or a less than symbol without the line underneath. And we abbreviate the alternative hypothesis with H sub A. So it'll look like this. So we're going to talk about how we do the test in later videos. But what we're going to do is we're going to do some calculations, and then we need to decide whether to reject the null hypothesis or not reject the null hypothesis based on our results. So if we reject the null hypothesis, this means that we have enough evidence to support the alternative hypothesis. And so we can conclude that we have evidence to support H sub A. If we do not reject the null hypothesis, this means that we do not have enough evidence to support the alternative. So our alternative hypothesis is often going to come from some sort of claim or some sort of question in the problem, and then we're looking for evidence to support that. So in my orange juice example, my hypotheses would be these. My alternative hypothesis is that the mean amount of orange juice is not 32 ounces. So I'm questioning whether the machine is working properly, if it's actually putting 32 ounces in each bottle of orange juice. My null hypothesis is always the opposite of the alternative. So if my alternative hypothesis is that they're not equal, my null hypothesis is that they're equal. And I always find it easiest to start with the alternative hypothesis when I'm writing these, and then I write the null hypothesis second. So even though when we see them, we normally see them listed like this with the null hypothesis first, it's actually easier to start with writing the alternative hypothesis. So in this example, I have the registrar at a university, and they're claiming that undergraduate students work on average more than 20 hours a week. So we have this on average. That tells us that we're dealing with a mean or mu. And the claim is that they're working more than 20 hours a week. So unlike my orange juice example, in this example, I have a direction that I'm thinking. I'm thinking that it's more than 20. So I use that when I write my alternative hypothesis. My alternative hypothesis is going to be that mu, the mean, is greater than 20 hours. And so remember, when we're writing these, the symbols we're using for the alternative hypothesis are always one of these three symbols: not equal to, greater than, or less than. If I have a sense of the direction, I use greater than or less than. If I don't, then I use the not equal to symbol. So since it's more than 20 hours a week, my alternative hypothesis is that mu is more than 20 hours. Then when I write my null hypothesis, I write the opposite of that. So the opposite of more than 20 hours is less than or equal to 20 hours. Null hypothesis always has the equality. So it has the equal to line or the equals sign in it. So my null hypothesis is that the mean is less than or equal to 20 hours. And so the key idea here with null and alternative hypotheses is that they're always opposite in terms of the signs that you put in them. So I would never have a greater than symbol in both my null and alternative hypotheses. They're always opposite signs. So let's look at another example here. Example 9.2. It says a machine is set to fill cracker boxes with 20 ounces of crackers. Technicians want to determine if the machine is working properly. Write the null and alternative hypotheses. So this one is pretty similar to my orange juice example. I don't know whether the machine is overfilling the cracker boxes or underfilling them. So for my alternative hypothesis, I'm going to go with the not equal to symbol, that mu is not equal to 20 ounces. And then my null hypothesis is going to be the opposite of that, which is that mu is equal to 20 ounces. So my question is the machine working properly? Or is the machine not actually putting 20 ounces in each cracker box? My null hypothesis is that it is working properly, everything is fine, and nothing needs to be changed. So the last thing we're going to talk about here in this section is this idea of type 1 and type 2 errors. So we could make a wrong decision if our sample happens to include individuals that are far from the true population mean. So for example, in my cracker problem, it could be that the machine is actually working properly, but I could just happen to get a bunch of boxes in my sample that are underfilled. It could be that my sample is not actually representative of the entire population of cracker boxes. And that means that we have made an error. So if that were to happen, that would mean that I would, so if the machine was actually working properly, but my boxes all happen to be underfilled, then I would reject the null hypothesis, but the null hypothesis was actually true. So if the null hypothesis was actually true, and I rejected the null hypothesis, I have made a type 1 error. So looking at this chart, there are kind of 4 possibilities here. State of nature means what is actually true. And then the decision side is what decision I'm making based on my hypothesis test. So if the null hypothesis is actually true, and I conclude that the null hypothesis is true, then that's the correct decision. If the null hypothesis is actually false, and I concluded that it was false, that's also the correct decision. If the null hypothesis was true, but I concluded that it was false, I made a type 1 error. And if the null hypothesis was false, but I concluded that it was true, then I have made a type 2 error. So in my cracker example, a type 2 error would mean that the null hypothesis was actually false. So the machine was actually not working correctly, but I happened to get an average that was close enough to 20 ounces that I concluded that it was working correctly. So we have another example here that's going to show the difference between these two types of errors. And in this situation, my null hypothesis is not pregnant and my alternative is pregnant. So a type 1 error, or a false positive, is when the person is not actually pregnant, but the doctor is telling them that they are pregnant. So the null hypothesis is true, but the doctor is rejecting the null hypothesis and claiming that there's evidence for the alternative. In the type 2 error, or the false negative situation, the null hypothesis is not true, and the doctor here is saying that they're not pregnant, so they're failing to reject the null hypothesis. So they're saying there's evidence that they are not pregnant, not enough evidence that they are pregnant, even though in the picture it looks like there's evidence that they are pregnant. So the situation here is that they are failing to reject the null hypothesis, but the null hypothesis should have been rejected because it looks like there's evidence for the alternative.